Okay, so what we want to do, we've got a table here. We have x values, the same as the x values we have over here. We have the predicted y value and we have the observed y value. And then we're going to have another line for the deviation, another one for the deviation squared. Squared deviation, okay? Make sense?
Yep.
So what do I mean by predicted y?
The y that your equation gives.
Yeah, the y you get from the equation, exactly, okay? So that would be 3 plus 9 halves, right? So I'll write that out, small but hopefully neatly, which is a little bit questionable in my case.
15.
And that's 15 halves, right? Which would be 7 and a half. Now, the observed y was 7, right?
Yeah.
So we see we can compare the predicted y with the observed y, okay? And the deviation is the observed value
Deviation is a half. 7.
Wait a minute, which way do I want to do that? I'm having a moment of... Okay, yeah, we want the predicted value minus the observed value. And that's 1/2. Because the predicted line is a little above the observed point, right? Okay? And the square of that deviation is 1/4. Okay? Make sense? Okay. So then we do the rest of our predictions. We're just adding 9 halves to the x value, right? Well, that's 12 halves and 9 halves is 21 halves. That's 18 halves and 9 halves is 27 halves. That's 24 halves and 9 halves, which is 33 halves. Our deviations, 21 halves minus 11, right? Okay? And that's going to be minus, well, okay, our observed is 11, and our deviation is negative 1/2. When we square that, it's still 1/4. Okay? Now, I'm not going to go through the details of how I calculated that. I just did this minus this, right?
Yeah.
And 11 is 22 halves, 21 halves minus 22 halves is negative 1/2. Okay? So we don't need to explain that in detail at every step. You know how to do that. Okay? So then our next y value is 15, which is 30 halves, which means that I have negative 3 halves here. And that squares out to give me 9/4. And then our last point, 16. Okay? That's 32 halves, and now our deviation is 1/2. So the squared deviation is 1/4. Okay? Make sense? Now, if we want to average these, our total deviation would be negative 1 in this case. 1/2 and 1/2 is 1, minus 1/2 minus 3 halves is 2. Minus 2, so 1 and minus 2 gives us minus 1, right? So I'll just write
86 is 21 half. That's the prediction.
total deviation is minus 1, the average deviation is minus 1 divided by 4 since there are 4 points. Okay? Now I suspect that if you get the equation of the straight line through the first and last points, which is y equals x plus 4, okay? Well, 9 halves is 4.5. This line is just half a unit higher than this line, okay? The average of your deviations might end up being the same, okay? There's another thing you could calculate, which would be the average of the absolute values of your deviations, which might or might not be the same, okay? We don't worry that much about the average of the deviations because it's the average of the deviations squared that we want. So, total of the squared deviations is, well, it's 12 fourths. You got 1, 1, 9, and 1, right? Adds up to 12, is all fourths, so it's 12 fourths. Well, total deviation is then 3. Average squared deviation is then 3 divided by 4, because you're going to divide the total deviation by the number of points, right? Okay? Make sense? Now, if we calculated this based on this line, you can verify this for yourself. The line would be y equals x plus 4, right? So when x equals 3, well, you get 0 deviation for the first point and 0 deviation for the last point, right? So it'd be 0 plus some number that we'll figure out plus 0. Now the second and third numbers will be the deviations for these 2 points, right? Okay? So our prediction, if y equals x plus 4, would be 10, and our deviation would be 1, right? So our deviation of this point would be 1, and then 9 plus 4 is 12, okay? And our deviation would be 3. Okay?
Wait.
9 plus 4 is 13.
Yeah, wouldn't it be? Wait.
Oh, wait, 9 plus 4 is 13, right?
Yeah.
And besides, 3 squared isn't 3.
Yeah, that's what I was.
So
about to
all
point out.
kinds of mistakes there, but okay, that makes it 5, right? So I think I know what I was thinking, and it's a little bit scary. Okay, so that's more correct. Okay, so average square deviation is 5 fourths. So this is an improvement over this, right? And it's also an improvement, well, interestingly, no, our average deviation would be 3 fourths, our average squared deviation 5 fourths here, compared to average deviation of negative 1 fourth here, and squared deviation 3 fourths. So we have an improvement, a significant improvement in the average of the squared deviations, which means that this line is better than this one. Do we understand that? Okay. Fairly complex process, but the steps are really kind of easy. If you just understand how to put them together, that's the challenge.